Unit 2, First-degree relations with one placeholder. Part A, Basic equations and inequalities. Lesson 1, Solution statements and solution sets. Objective, to interpret solution statements and show the solutions using set notation and number lines.
Having given extensive consideration to 4 of the 5 parts of mathematical speech, it is now time to look carefully at the 5th part of speech, the placeholder. More specifically, we will begin to develop a systematic approach for finding solution sets of open sentences, more commonly referred to as solving equations and inequalities. Before we get to procedures, however, we are going to make absolutely sure that you can interpret solution statements correctly and show solution sets clearly. So, in this lesson, we will consider the various types of solution statements and their related solution sets. For example, if you arrived at this statement when solving an equation, how would you show your solution? There are 2 acceptable ways to show a solution set. One is to show using set notation a roster or listing of solutions. In this simple case, the solution set S is the set 4. The other approach is a graphic representation on a number line of all solutions. Again, in this case, that is very simple. The solution is 4. Either of these 2 approaches would give sufficient information. Generally, for simple equations, however, the solution statement itself is sufficient. Now, let's consider a case that is a little more involved, solution sets for simple inequalities. Suppose you arrived at this statement, n is less than or equal to 8. It is obviously impossible to show a solution set here using a roster because we would have to show fractions as well as integers. We could show it using a rule, however, the set of all numbers represented by n such that n is less than or equal to 8. This still doesn't tell us much though, does it? So how about a graphic representation on the number line? To show the solution set that way, we must ask 3 questions. First, where would n be equal to 8? Now notice we didn't say it had to be equal to 8. We just need to know where our boundaries are. We draw a small circle at the point for 8 on the number line. Second, can n be equal to 8? Because the relation symbol says is less than or equal to, the answer is yes. N can be equal to 8. So we color in the circle at 8 to make it a part of our solution set. Third, which way should I shade the number line relative to the 8 to show all of the rest of the solutions? You may be able to see this by inspection, but again, we don't need to guess. Let's just test a number. Suppose we substitute 0 for n. Would the statement be true? Yes. 0 is also a solution, so we must shade to the left side of 8. Otherwise, 0 wouldn't be included. In fact, this is about the best we can do to check solutions of inequalities. Test a small sample. Because there are so many possibilities, this is the most straightforward way to illustrate the solution set for an inequality. We now have a better feel for the range of solutions for this case. Let's consider one more example of an inequality, because they seem to be a little more complex. Suppose you arrive at this solution statement. Again, the solution set could be written only by the rule method, the set of all numbers represented by z, such that z is strictly greater than -3. That is accurate, but it will be more clear if we show it on a number line. First, where would z be equal to -3? At -3. We place a small circle at that point. Second, can z be equal to -3? No, because the relation symbol says strictly greater than, so we don't color in the circle. -3 is not in our solution set. Third, which way should I shade on the number line relative to -3? A quick test of the number 0 again shows that it is also a solution. So we must shade to the right of -3 to make sure 0 is included. The ability to accurately and clearly show solution sets of equations and inequalities is a critical skill that is essential to your work with algebraic relations. And if you will remember the 3 questions given in this lesson, your work with inequalities will be much easier.